Okay, let's talk about the second part. Yeah. So so for a teaching in a university business case, a business event, we inferred this ER diagram earlier, right? So we have a professor. Okay. Yeah. So we have a professor entity, semester entity, and the course entity, and we made a teach relationship like this. So that's what we did earlier about the business event, teaching in a university. And we may want to record more information here. So what if we want to record the number of courses offered in a university? So in a university, there are multiple courses, and we may want to record this kind of information. How many courses are offered by this professor and how many courses are offered in this semester? We may want to know that kind of information. So we call this kind of information, we call this kind of a field as an aggregated field. So basically, it's an information which should be calculated using the data inside your database. So basically, to know how many courses are offered, the number of courses, we have to count how many courses are stored in our database system. So basically, aggregated field is defined as a calculated field by taking total, sum, or average function. So something like this. We may want to store the total number of courses offered in a given semester. We also may want to store the total number of courses offered by each professor. And we also may want to store this information, the total number of courses offered by each professor in a given semester. So we want to know how many courses each professor is teaching in every semester. The question is this: when we have an aggregated field, where should we put that attribute? Where should we put that field in our ER diagram? So let's look at one by one. The first one is the total number of courses offered in a given semester. So the most important thing here is this: when you have an aggregated field, sometimes you might be confused because you may think about how this information is calculated. To calculate the total number of courses offered in a given semester, you have to look at this, right? And you have to look at this, and you have to look at this information and see how many courses are offered. However, in the database design, you shouldn't think about how the information is calculated. That's another thing. In the database design, you have to only think about where this information should be stored. Basically, what kind of entities this information depend on. So this one, total number of courses offered in a given semester. What it means is that in every semester, you will have this information. Basically, this semester, 2022, we'll have a total number of courses information, the value. And next semester, we'll have a different value. And after that, we'll have a different value like this. So basically, the total number of courses offered in a given semester, it only depends on semester. Each semester will have a different value. So we simply store it inside semester entity. So semester entity, we make an additional attribute, which is a total number of courses per semester, and we store the value here. Then every semester, we have a different value. So that's what you can do. Same thing for this. The total number of courses offered by each professor since he or she joined the university. So for every professor, we want to know what's the number of courses he has been teaching. Very simple, right? Same as the earlier example. It only depends on the professor. So inside the professor entity, we store number of courses taught. So basically for every professor, there will be different numbers stored. And that number will represent the total number of courses taught by this professor. The next one, total number of courses offered by each professor in a given semester. So not just about professor, not just about semester. So in each semester, there are multiple professors, and we want to know for a certain professor in a certain semester how many courses he is teaching. Currently, in this design, there is no place to put that information because we cannot put this in the professor table because it also depends on semester. We cannot put this into semester entity because it also depends on professor. I mean, yeah, professor and yeah, semester. And we are not able to put this into teach relationship because the teach relationship is not just about professor and semester. It also involves course. So we are not able to put it there. It only depends on semester and professor. In that case, what we want to do is just simply make a new relationship between semester and professor to represent this information. So professor can be in many semester, and each semester may have many professor, right? Then it's many-to-many relationship. So here we put this total number of course information in this relationship. So the answer for this will be like this. So we make a new many-to-many relationship offers here. So professor offered class in semester, right? So it's many-to-many relationship. And inside this relationship, we simply store the number of courses offered attribute. So for a certain professor teaching in a certain semester, we'll have this value stored here. So that's how you determine where to store obligated field. So if there's no entity or relationship to store obligated field in your current ER diagram, you can create a new relationship and you can new many-to-many relationship, and you are able to store that information into that relationship. So that was the main point here. The next one is a time entity. So time entity is something like this. It's an entity which represents time-specific information, something like a year, month, or day. So this is represented like this in the ER diagram. So basically, just like any other entity, you use the box shape and you put year or month or date as a name of entity, and you use year, month, or date as a primary key. So this time entity is actually useful to store aggregated information, something like annual sales or or monthly sales. So we usually use this information. We usually use this time entity to store this type of information. So where to record again? So let's say that we want to record the total number of courses offered by each professor in a given year. So currently, we don't have any time entity here. But we want to now store that information. And also, we want to store total number of courses offered in a given year. So what we can do is basically this. So here's the answer. We can create new time entity year. And for the second one, the total number of courses offered in a given year, we can simply store inside this time year entity. Then basically for every year, we'll have this value. So every year, we'll have the number of courses per year stored inside the year entity. And for the number of courses offered by each professor in a given year, we can create this additional relationship here, which connect the professor and year as many-to-many. So in each year, there are multiple professors, and each professor, they will work across multiple years. So this relationship will represent a certain professor working in a certain year, and we can add this attribute number of courses offered. So for a certain professor working in a certain year, we'll have this value number of courses offered in that year. So that's how you can utilize time entity with the aggregated field. So that's easy, right? So here is one more exercise. There is exercise 5. So basically, let's read this together, and I'll give you some time to think about it by yourself. So currently, if you look at the year diagram, basically it's about professor teaching in a university, right? So professor teach a certain course in a certain semester like this. So there are 3 entities connected together using the teaching relationship. So our goal is this. We want to record the teaching score information. So for you, when you take a course, after taking a course, you will get a grade, right? As a professor, after we teach your course, we'll receive a teaching score from you, basically. So we want to prepare a database system which is able to store teaching score information. And what we want to do is this. Specifically, we want to record score of each course taught by each professor in a given semester. So that's the number one. So first, we want to store score information. And number two is this, average score of each professor in a given semester. We also want to store that information. So every semester, professor may teach multiple courses, and we want to know what's the average score of that professor in that semester. Number three is the average score by each professor. So each professor may teach multiple courses across multiple semesters. We want to make an average, and we want to store for each professor. Number four is the average score across all the courses taught by all the professor in a given semester. So it's a semester average, right? Every semester there are multiple courses taught by multiple professors. We want to make an average, and we want to calculate the semester average score. The last one is the average score of each professor in a given year. So it's yearly average of a professor. So we want to score that, and we want to store that information too. So there are 5 aggregated fields we want to keep in our database design here. So I'll give you about 3 to 5 minutes again. So think about this, where we are able to store these 5 information in our ER diagram here. So think about that within like 3 to 5 minutes, and then I will show you the answer. Okay, let's, if you are not done yet, let's do it together. Okay, the first of all, the score information. It's about, okay, it's about a certain each course taught by professor in a given semester. So it depends on 3 things, right? Professor teaching a certain course in a certain semester, and as a result, here you get a score. So that is here, this relationship teach, right? A professor teaches a certain course in a certain semester, and it's also many-to-many relationship. So as a result, he will get a score. So first information will be stored here. And the second one, average score of each professor in a given semester. So it depends on professor and a semester. So we don't have that relationship here yet, so we simply make it connecting professor and semester. So professor may teach across many semesters, including at least one. And each semester there might be many professors, including one like this. Then it's many-to-many relationship, and here we can store the second information, which is average score. And the number 3, average score by each professor. So that's simple. So we simply want to calculate what's the average of each professor. So that can be stored here in the professor entity. So each professor will have their own score. And number 4, average score across all the courses taught by all the professor in a given semester. So every semester we want to calculate what's the average in that semester. So that one, simple. Again, here in the semester entity, we can store it. So every semester we'll have that information. And the last one, number 5, average score of each professor in a given year. So it depends on a professor and a year. So currently we don't have a year, so we can create year entity here with the year primary key, and we can simply connect professor and year. So in each year, for each professor, they may work at least in 1 year across many years. In each year, there's at least one professor, and there are many professors. So it's a many-to-many relationship. So here we can store the number 5, average score of each professor in a given year, like this. So basically, this will be the answer for the exercise 5. Okay, so you can compare with what you did. You can compare this with what you did in your paper. So if you have any question, you can ask me. Okay, if not, let me go to the next one. So next one is integrated ER diagram. So basically, after you work on conceptual data modeling, you will have multiple ER diagrams. So basically, each firm is when each firm is operating a business, there are multiple business events, right? And for each business event, we infer the business rules related with that event, and we design the ER diagram. So if the company has multiple business events, you will have multiple ER diagram. And the last step is basically combining all these related sets of ER diagram together and to come up with final big integrated ER diagram. So let's think about our example earlier. So we talked about in the university, we talked about a business event of a professor applying for a parking permit. And we also talked about another business event, which is teaching in a university. For the first business event, professor applied for a parking permit. We created this ER diagram. And for the teaching in a university, we created this ER diagram. So we have 2 business events here, and we created the ER diagram for each business event. And how to combine these ER diagrams together? It is actually very simple. You have to look for something common. So you have to look for entity which are used in both diagrams, but actually they are the same. So for example, here there is a professor. Change this into pen. Okay, so there is a professor entity here in the first ER diagram, and the second ER diagram we also have a professor entity. So those 2 are actually the same entity that represent the professor information. So as you see, all the attributes are also the same, right? So we combine these 2 together. There is no need to have a separate professor entity. If you have 2 different entities representing the same information, then it's a data redundancy. So we don't need to do that. So we simply remove one and combine them together. So we make it as something like this. So there's one professor entity, and this part is representing the first business event, which is about professor applying for a parking permit. And this part is representing the second business event, which is about professor teaching in a university. So that's it. Basically, this is how you can combine multiple ER diagrams together to create an integrated ER diagram. So this is the final step. So this is one here shown is an integrated ER diagram that represents two business cases which exist in the university. So that's the final step, yeah. And once you have an integrated ER diagram, the next step is implementation. So which we are going to talk about it next week. So next week we are going to talk about when you have an integrated ER diagram, how you translate into the relational model and how to implement it in the MySQL actually. So that's basically all about how to do conceptual data modeling and how to come up with ER diagram from the business event in the company.